All right, in the previous lesson, we looked at imaginary numbers. We know that the square root of -1 is always equal to I. So if we are multiplying the square roots of two negative numbers together, if you did this on Desmos, it would tell you it's undefined due to the fact that Desmos will not simplify the square root of a negative number. So what we have to do is to break this problem down, and I have rewritten it in this step. I'm going to first of all pull out that -1, and I'm going to rewrite the problem as the square root of -1 times the square root of 27. On the square root of -32, I'm going to do the same thing, square root of -1 times the square root of 32. The square root of -1 we know is I, so for each of those I'm going to bring down the I. The square root of 27 I'm going to break apart to where one of the factors is perfect square, and that is going to be 9. So I do the square root of 9 times 3, which is 3 times the square root of 3. On 32, I find the largest perfect squared factor that goes into 32, and that's 16. And I break that down as the square root of 16 times the square root of 2, which is simplified to be 4 times the square root of 2. I'm now multiplying the parts together. Outside, I have an I times 3 and an I times 4. So I'm going to multiply the numbers. 3 times 4 gives me 12. I times I is I squared. I then multiply what's left under the radical, and under the radical we multiply the square root of 3 times the square root of 2, which is 6. I cannot leave an I in an answer that has an exponent larger than 1, so I know by definition that I squared is -1, and I replace it and multiply to get -12 times the square root of 6. All right, a complex number is a number that contains a real part and an imaginary part. Examples of complex numbers: 2 minus 3i, where the real is 2, the imaginary is -3i. -9 plus 6i, the real part is -9, the imaginary part is 6i. 7i is a complex number due to the fact that it has no real part, and that real part could be considered to be 0. Same as 8. 8 is going to be a complex number because if I look at it, I could write it as plus 0i. All right, we are going to be looking at adding and subtracting complex numbers, and that is simply combining the like terms, the like parts. We have -3 and 7, which are like terms, and we have 5i and -6i. So on Desmos, I'm going to type in -3 plus 7, which is going to give me 4 for the real part. I'm going to type in 5 minus 6, which is going to give me -1 for the imaginary part. So my answer is going to be 4 minus 1i, or we know normally we do not have ones in front. It would be written as 4 minus I. On the second example, we are subtracting, so you have to make sure that when you combine them that you are subtracting. We underline our like terms. -9 minus 3 is -12, so the real part is -12. We have 2i minus -4i, and we know anytime we have minus a negative that is the same as plus a positive, so 2 plus 4 would give me 6i. All right, on this example, we are multiplying using distributive property. We always want to make sure that we remember that we never leave answers with I squared or higher in a problem. So we are going to distribute 2i times 6, which would equal 12i, 2i times 3i, which is 6i squared. By definition, we know that I squared has a value of -1. Therefore, anywhere I see an I squared, I'm going to replace it with -1, and I simplify to get 12i plus -6. In algebra, we normally do not look at plus negatives, so this would be written as 12i minus 6. All right, this one's going to take us back a little bit. We have two complex numbers multiplied together. Both of these are binomials, and we have to remember that in order to multiply binomials, we are using either full method or we can use box. I prefer to use box, but if you prefer to use full, that is perfectly fine. So in the box, it looks like a tic-tac-toe board. We're going to put that first binomial, I put it across the top, 2 plus I. I put the plus in the box to let me know, remember that that is a positive. And down the side, I'm going to put the second binomial, which is -5 minus 3i. This is kind of like an old multiplication table. We multiply what's on the side times what's on the top. So I'm going to do -5 times 2, which is -10. -5 times I, which is -5i. I have -3i times 2, which is -6i. And -3i times I, which is -3i squared. I then write my four boxes. I have -10 minus 5i minus 6i minus 3. And instead of putting the I squared, I want to replace it with what it is equal to, -1. And then simplify my like terms. -10 plus 3 would give me -7. -5 minus 6 would give me -11. All right, in this example, you're given the complex number -4 plus 5i, and you're asked what is the real part. The real part is always going to be the number without the letter I. Therefore, the real part would be -4. The imaginary part of this number would be 5i. All right, we are combining like terms. So on this example, we're adding two complex numbers together. We have underlining the like terms, 5 plus -7, and when I type that in, I get -2. I underline my I's. Make sure that you are careful and that you recognize that because that minus is in front of the I, that makes that -2. So I combine -2 plus 8 on the calculator to get positive 6i. On this one, we are combining like terms. We have three complex numbers. The first number is -6 minus I plus 5i minus the complex number 11 plus 13i. I'm going to underline my like terms. I have -6 and I have an 11. I am subtracting that 11. So when I type into Desmos, I'm going to get -6 minus 11 is -17. Then I do my I's. I have -I, I have 5i, and I have 13i. So on Desmos, I'm writing this in as -I is -1 plus 5, and I am subtracting the second imaginary part, which is -13. Therefore, when I simplify that, I'm going to end up with -9, so it would be -9i. Correct answer would have been answer A. All right, we are adding two imaginary radicals together. Therefore, what we have to do is we have to simplify each of those radicals. First thing I'm going to do is pull out that square root of -1. And I know that the square root of -1 is I. So when I see this problem, I know immediately, because there's a negative inside, I can pull that out as I, and I'm going to end up with 3i times the square root of 32 plus I times the square root of 162. I have to break 32 down, and what I'm doing is I'm using those perfect squared numbers, 4, 9, 16, 25, 36, 49, 64, 81, we'll go to 100. All right, so when I divide, I do 32 divided by 4, that gives me 8. But I have to make sure it is the largest perfect square factor. 32 divided by 9 is a decimal, but 32 divided by 16 is 2. Therefore, I break square root of 32 down as the square root of 16 times the square root of 2. On the square root of 162, I'm going to find the largest factor, so I would divide by each of those, and the largest perfect squared factor that goes into 162 is going to be 81. Therefore, I break 162 down as the square root of 81 times the square root of 2. And then I simplify. 3i times 4, because the square root of 16 is 4. And over here, I can simplify the square root of 81 to be 9. So when I multiply 3i times 4, I get 12i times the square root of 2. I times 9 gives me 9i times the square root of 2. And because what's inside the radical is the same, that means that I can combine them together, and I'm going to add 12i plus 9i to get 21i times the square root of 2. All right, on this problem, we're multiplying 3 complex numbers together. The real parts are all zeros. So I'm going to multiply the number parts, negative 4 times 3 times 4. I'm going to multiply the imaginary parts, I times I times I. I went ahead and just did I times I to get I squared because I'm very familiar with the fact that I squared is equal to negative 1. I also could have done my table, which is going to be I to the 0 power is 1. I to the first power is I to the second power is negative 1, and I to the third power is negative I. So if I remember that I to the third power is negative I can automatically just replace that. So I'll change I squared to negative 1, and I get 48i. All right, this one again, we're multiplying 2 complex numbers together, so I chose to do box method. Again, you could do full method. You can multiply using distributive property, 6 times 5, 6 times negative 4i, negative 4i times 5, negative 4i times negative 4i, and then simplify. So in my box, I have 5 times 6 is 30. 5 times negative 4i is going to be negative 20i. Negative 4i times 6 is going to be negative 24i. And negative 4i times negative 4i is 16i squared. So I bring those boxes down and I combine my like terms. I'm going to replace I squared with negative 1, so that is going to give me negative 16. I combine my i's, negative 20 minus 24 is negative 44, and then I combine the real parts, 30 minus 16 is 14. So the answer is B. All right, on this problem, we have to remember that if we have a binomial squared, that means that you're multiplying that binomial times itself. Therefore, negative 2 plus 8i squared is the same thing as negative 2 plus 8i times negative 2 plus 8i. Doing the box method, I'm multiplying those together. I'm going to get negative 2 times negative 2 is 4. Negative 2 times 8i is negative 16i. 8i times negative 2 is negative 16i. And 8i times 8i is 64i squared. rewrite this as 4 minus 16i minus 16i. I replace I squared with negative 1, so I get minus 64. I combine my like terms. I have 4 minus 64, which is negative 60, and negative 16i minus 16i is negative 32i. So the answer should have been answer D.